chat right now. You can go ahead and say hey to all of us. Max in chat is saying Python Tuesdays. Hello, world. So give us a couple of seconds here until we make sure that we're live. All right, cool. It looks like we're good. So, hi, everyone. Welcome to another edition of CS101. My name's Alex. I'm here with Carolyn.
Hi, everybody. This is Carolyn. We're both curriculum developers here at Codecademy. Alex is probably a more familiar face since he's taking point on this live stream series. But
you've been around, Carolyn.
Yeah, a couple of times, but I'm not seasoned at all. But yeah, every week it's a mixed bag of people, I think.
Yeah,
of fellow developers.
Right now we're streaming on a couple of different platforms. Carolyn and I are primarily going to be looking at the YouTube chat. So if you're watching us on Twitter or Facebook, feel free to come over and join us over on YouTube. I'll try to pull up the Facebook chat as well so I can interact a little bit in there. But really, we're kind of looking mostly at YouTube. So I see people in the YouTube chat are saying hi to us, which is cool to see. Carolyn, do you want to give a little bit of a high-level preview of what we're going to be talking about today?
Yeah. Okay. First, for just housekeeping, I can't see the YouTube chat right now. If Alex, you could just link that to me.
Yeah, sure. I can link that to you.
Thank you all for your patience. Okay, but today we're following this CS101 live stream series where, so far we've covered a couple of basic topics that you need to know for computer science. We've been using Python as the language to kind of practice our CS knowledge. And today we're going to be talking about dictionaries, which is a new, slightly more, not complicated, but it allows more functionality than lists and some, more tiny data structures. This is going to be a more built out type of data structure where you're going to be learning about how to create a dictionary and how to access a dictionary and modify entries in a dictionary. And we can go into the syntax once we hit our lessons, but there's 2 lessons for this dictionaries kind of like module. The first one's going to be creating a dictionary, how to add keys and values. We'll explain what keys and values are in the lesson. And then the second lesson will be, I think, updating the dictionary and I think accessing like either all the values or a single value. And the code challenge is a crowd favorite. It's where it's essentially 3 code challenges and you're applying the knowledge from those lessons. And if you're watching the live stream, you'll be watching us kind of tackle the code challenges towards the end. So yeah, that's what we got for today.
Yeah, I linked the link in the YouTube chat right now. It's also in the YouTube description. But yeah, we're going to be going through the 7th module in this CS101 course. And one of the things I think is interesting is that this whole course, we're kind of trying to emulate what your intro computer science class might be if you're in high school or maybe your first year of college. And I think traditionally the second course in college is all about data structures and algorithms. And so I think that we're kind of to the point where we're starting to see what that content might look like, where we've seen lists, we've seen loops, we've seen kind of the foundational things. And now we're getting into slightly more niche of like, okay, why would I want to organize my data in this way rather than with a list? So as we're reaching the end of the series, we're kind of getting previews as to what you might see in, a second semester computer science course.
Mm-hmm. Mm-hmm.
Cool. All right. You want to share your screen, Carolyn, and we can get started?
Yeah.
Awesome. And yeah, I'm going to be keeping an eye on the chat as we go here. So if you, Carolyn is mostly going to be having her, coding along. So if you have questions, feel free to post them in the chat and then I can ferry them along to Carolyn.
Yeah. Cool. So I've shared my screen now. I'm in our little live stream series syllabus. So this is the link if you all are wanting to follow along. And I'm going to scroll down to this dictionaries module. We've got 2 lessons in an article. So I'm going to just jump right into the lesson.
Let's do it.
Cool. Cool. So firstly, this intro to the lesson is, what is a dictionary? And essentially we can think of it as if you think of like a regular dictionary, right? You're looking for a word, and what you find when you find the word is its meaning, right? So it's essentially a pairing of, I'll call a key. That's what you're searching for. And then the value is what is returned, right? So a dictionary is just that, an unordered set of key value pairs. So let's say we have this example here where we've got these menu items at a cafe, and we have each item at the cafe being worth X number of dollars. So what we can do is actually store this menu as a set of key value pairs, right? So oatmeal maps to 3, avocado toast 6, carrot juice 5, etc. And in this little block of code, you already see the syntax. We call the dictionary menu, and the whole dictionary is surrounded by curly braces. And then each of the key value pairs is just, in this case, we want to use a string for the food names, and then an integer for the prices. So the key and value are separated by colons, and each pair is separated by commas. And it doesn't matter what order they're in.
Cool. Yeah, I think that's a really big point, and something that's different from our previous data structure, which was a list, where really the only thing that the most important thing about the list was the ordering, where we could say, okay, get me something at index 2, or get me something at index 10, or get me something at index 0. And that's really how we interacted with lists, was knowing in what order things are coming in. That's totally different in dictionaries here, where the thing that we're really going to be interacting with a lot are these keys, which we can define for ourselves as a string, or we'll see what else we can define keys as later on.
Cool. Yeah, so there's this example in the little story here, and then there's another set of there's another example where we want to set in these instructions where we want to set temperature sensors in the house. So we want to map the room to the temperature in Celsius, right? So in this instruction, just added a new sensor called pantry, and it should be 22 degrees. So we want to add this pair to the existing sensors dictionary that's already set up in that little code editor. So what I'm going to do is, I know that each pair is separated by comma, so I'm going to create a new pair. I need a new comma. And I'm going to just type the new pair, which is pantry, and colon. It's good practice. It's a little bit easier to read if you add a space between the colon and the value. So the value here should be 22. Cool. So that looks right. And now we want to kind of see this other dictionary here that's called num cameras. So we want to uncomment that line. We'll run this. It says that we're expecting a syntax error. That means that there's some sort of typo, or doesn't really follow the format that Python likes to read in. So let's try to fix this to make it run. It looks like, so we've got the colons between each key and value, but the pairs are not yet separated by commas. So I'm going to add in those commas. Cool.
Nice.
Nice. And we can even add another line to print that num cameras dictionary here.
Yeah, and one thing to think about as you're starting to work with dictionaries is already you can kind of see the type of data that we're working with has that like key value pair, right? Where
Mhm.
we have something that's linked to something else. So
Mhm.
I think the example here was the living room was being set to 21 degrees. I don't know what the backyard example is. What is it? The number of cameras in each area around your house. So our backyard has
Mhm.
6 cameras in it. Our garage has 2 cameras in it. And so you can think about, you probably could store this information in a normal list, but you might have to
Mhm.
either store a list of lists of like
Mhm.
backyard 6, or maybe you would just have
Right.
to remember the first thing in your list is, you store
Right.
6 and you just have to remember it's a backyard. So it's like you
Right.
can always make this work. You can always hack together a solution, probably
Mhm.
using whatever um, data structure you're comfortable
Mhm.
with. But being able to recognize, like, oh, this type of data of something mapping to something else means
Yeah.
that it's a really good use for dictionaries. Like that kind of intuition, I think, is
Yeah.
something that's important.
Yeah. So I mean, one of the most like important applications of like a dictionary with a key value pair is if your web browser is sending data, right? So it if it just received like a series of like numbers and codes, it wouldn't know what to do with them. It would have to be, associated with um, the the user entered like this password and this name, and your device is this name, right? So it makes things a lot easier to. Um, it's essentially like a great organizing tool for your data.
Yeah,
Uh,
JavaScript uses this all the time. I mean, another one of the things that we want to stress in this series is that these concepts are pretty fundamental to any programming language.
mhm,
Where if you learn it in Python, you'll definitely be able to then go to JavaScript and see very similar things start to happen. I would even say JavaScript uses this more than Python, where like
mhm,
everything is an object in JavaScript. But
mhm.
yeah,
Yeah.
very applicable to different programming languages.
Yes. And you'll find that a lot of problems that you want to solve, dictionaries really come in handy. Um, okay, so let's make a dictionary from scratch. The last exercise, we kind of had it handed to us. Um, so I'm going to kind of like skip past the narrative here and just create this dictionary in the instructions that we want to call translations. So um, Python, you can directly uh, declare a name, declare a variable. Um, and we want to map the English words to their definitions in Sindarin, which is another language. Um, Fantasy language, I guess. Cool.
Let's
So
see.
it
Yeah.
seems like both of the key and value should be a string in this case. So I'm gonna, okay, I'm gonna make that, I'm gonna follow the best practices for spacing. From course and whoops. Cool. So I created that dictionary there. Comma separated pairs, key values with a colon between, surrounded by curly braces. Um, cool.
You
Let's
want
move
to just
on.
print out that you want to just print
Oh
out that
yeah,
dictionary just to prove that it exists. I think that's always nice
yeah,
to see that our variable
yeah,
exists. And then
yeah.
another thing before we move on from this exercise, something worth pointing out is in
Mm-hmm.
this narrative. Um, so we our values can be very different things, right? So you can
Mm-hmm.
see in that last code block where we have Shuri, age 18, siblings T'Challa and Ramonda.
Mm-hmm.
You can see that, okay, our values can be anything from a string to an integer to a
Right,
list of strings.
right.
But so far, we've only seen the key, the thing that comes
Mm-hmm.
beforehand, be strings and I guess integers in that subtotal to total
Mm-hmm.
one.
Yeah. And your value can even be a list. So in this
Yeah.
example right here, it's saying, people that belong on different teams. You can be like, I'm looking for people on the cartography team. And then you'll return a list, Christopher, Juan, and Marco. Um, So it's really customizable. You can really add as many dimensions to this as you want.
Yeah, they can even be more. The values can be another dictionary itself, so you can have this like nested structure. So yeah.
Cool.
I think in a second we will see, yeah, invalid keys. So everything we just talked about was in reference to the value, but the keys is a little bit more constrained. So let's see what the deal with keys are.
Cool. So basically, there are certain things that we can't have as keys. So in this example right here, this dictionary that you're attempting to make has a list as a key. And so that will return you a type error because a list cannot be a key. It's because that list is an object that can be changed. So the way that dictionaries work, I mean, we're really lucky that these programming languages make it kind of easy for us. But on the like sort of back end of things, there are like hashing algorithms to essentially store the key in memory at some sort of location. And it's using these hash algorithms in order to also find your key, right, in the sea of keys that is the dictionary. Um, so that means that if the key itself can be modified, then that's going to basically mess with the hashing algorithm that makes this all possible.
Yeah, that's all of this is again a good example of stuff that you might get into in like your second semester CS class of like, okay, we might know what a list is and what a dictionary is and like good use cases to use them. That's kind of like the point of this type of exercise. But really then what you'll start to learn as you get more into computer science is how does this hash function that Carolyn is talking about, how does that actually work? What are the advantages and disadvantages of it? So if you're not familiar with, hash values and stuff like that, for now, I would say don't worry about it. Really, the focus is what are dictionaries used for? What's kind of like the format of data that we should be keeping an eye out for? And then as you get further into your computer science studies, you'll kind of learn to understand more of the like nitty gritty detail of how they work.
Yeah. So let's try to fix this dictionary in the instructions here. So firstly, like this dictionary scheme is not very practical because you would never be searching for a list, right? Like, hey, I'm looking for Johann, Rosemary, and Eleanor's last name. That's really impractical too because you have to write your list probably in the exact same order, and plus it's a type error. So it actually makes sense to flip these, and if we flip these, we'll actually have a valid key. So
Right.
what I'm going to do is make the last name the key, and the value will be the names of those siblings. So I'm going to do that for both pairs.
Yeah, again, a good way to think about this is an actual dictionary where you have a word that you look up its definition. This is kind of how we have a word, which in this case is the last name of the family, and the definition is the list of members that belong to it.
Cool. Nice. I'm going to move on to the next one, where we can create an empty dictionary. So that's pretty straightforward. You can add values to your dictionary later. You don't have to declare them all at once. So here I'm just demonstrating.
I would say this is probably the most common. You usually start with this, where you start with an empty dictionary and then add values over time to it.
Right. Because usually, you want it to be evolving. You want some sort of code to run to slowly add things to the dictionary. Very rarely do you want to hard code a dictionary, actually.
Yeah, what do you mean by hard code?
So hard code means that, so like in the previous exercises, like something like this, where we are basically adding pre-existing values and they're staying kind of locked, right? So they're being declared all the way at the beginning of the program. Those are values that are like in that box already. And it's, I mean, we can always add to a dictionary, but the hard coding, it basically like is you adding the data kind of painstakingly.
Yeah, exactly.
Yeah.
Very like manual labor, right? Kind of like
Yeah.
manual data entry. Whenever you see that, that's kind of what hard coding is about.
Yeah. So if I had like I don't even, never mind. I'm not coming up with a good example in my head right now.
Sure.
But this will come up again, and you can also, you know, search for hard coding, and a million people on the internet will be like, here are my stories. Cool. So like we said, you know, most times you're populating an empty dictionary. That means that we are always able to add a key. So this is a syntax to add a key to the dictionary. So essentially use these brackets. It's very similar to how you're indexing in lists,
Yep.
Except now you're kind of indexing by the key, which is really nice, actually. So for example, if we wanted to add this like cheesecake thing to the menu, we would simply say, hey, in the menu dictionary, add this entry called cheesecake and make the value equal to 8. So then now you can access that new entry in the dictionary. So let's create a new empty dictionary here called animals in zoo. So that's the empty curly brace. And we want to add, so it seems like what we want this dictionary to do is keep track of the number of animals. So I think I'm just going to complete this one checkpoint, and then we'll move on to the next one, because it's pretty similar for the next few. Zebras.
Plural zebras we wanted.
Plural. Yes. Okay, cool. And then you can do the same thing with monkeys and dinosaurs. You can set it to 0. I'm just going to print this here.
Yeah. And actually, do you want to print out your variable before adding zebras just to see it started empty and then we added zebras?
Cool. Yeah. Nice.
And I would even encourage, again, for folks that are kind of new to Codecademy or coding in general, doing stuff like that I think is really helpful, where even if, you know, you get our green check mark on Codecademy, I think it's still a good idea to kind of like play around with your code like that to see, okay, before I did this line 3 of my code, let me see what that variable actually looks like. And you can see it was empty. And then afterwards, let's see what it looks like. So I think sometimes you'll find that like, even after you get the green check mark, you might want to like do things like add more print statements or, you know, try to change values, see if you can change zebras to 10. Like, you know, I really encourage playing around with code, even if you've, you know, passed all of our tests.
Definitely. And print statements are always really clutch.
Yeah.
Cool. So we can also add like multiple keys by using this little update function. So update is a built-in function in the sort of dictionary like object. So it's a function that comes with all instances of dictionaries. So let's try it out directly here, where we're adding 2 new user IDs to this existing dictionary. So we'll use the dictionary name, and we'll do update, and looks like we want to add in our argument to that function of like a complete dictionary in itself. So like the dictionary that we want to, we can think of it as like an append. I think it's similar to append in list. So then inside of this, go ahead.
Really what we're doing here is that we're adding this whole new dictionary onto our existing one where, okay, we have Terracoder, we have Pro Programmer, we're going to be adding, and I think, Carolyn, you're adding
Oh,
stuff
I'm
not from the
adding the wrong
instructions,
thing.
but it's fine. We can probably
Yeah.
run it anyways. Yeah.
Yeah.
We're making the entire other dictionary with multiple keys that each have their own value and just kind of sticking it onto our existing dictionary.
Right. So this isn't correct, but
Yeah. And why don't we
okay.
print out user ID too?
Yeah.
Nice.
Cool. So now it's one single dictionary. They've kind of melded together. Cool. Let's move on to the next one. Definitely recommend looking at this lesson afterward and going through it more in detail if you want to, get the complete practice.
Yeah. One thing before we move on, sorry, Carolyn. I know
okay.
there's like there's always a million tangents that I want to go
Yeah.
into. One thing that I wanted to point out here was that this method changes the dictionary in place, which means that you, which like sounds very fancy, and you'll see us talking about like, oh, this method changes it in place, and this one doesn't. What this means is that notice on line 2, we don't have to reset user IDs equals user ID dot update. The method just does it automatically, and the variable is changed. We don't have to reassign the variable. In fact, if you do user IDs equals to user ID dot update, why don't we try that? And so just, set user IDs equal to that thing.
Yeah, I wonder what we get.
Yeah, so you now get none, which is really confusing. And basically what that's saying is that this method does the thing and then returns
nothing.
Yeah.
So let's just print the result of this line.
Yeah.
So that'll maybe give us more. Yeah, it just prints none. It returns none.
Yeah. So that's a really common mistake of having this in-place method that does something and then returns none. If you set your variable equal to the thing that thing returns, you could accidentally wipe out your entire dictionary, right? You could accidentally set the entire thing to the return value, which is none. So that's something to keep an eye out for, is that some methods are in place, which means you do it automatically, and some methods are not in place, which means that you need to reassign the result to a new variable, basically.
Yeah, definitely. Cool. Let's move on to the next one. So in addition to adding keys, we can also update the values in our dictionary, right? So let's say that in this menu that we had since the beginning, we want to change the price of one of the items. So in this case, avocado toast. But we know that there's already an entry with avocado toast as the key. We just want to update the value. It's grown in price, I guess, like everything. And basically, so right here, we can overwrite the value of the overwrite the value at a certain key. We can always update an entry to the dictionary, right? So let's try that in this example dictionary we have in our code editor. So it's for Oscar winners. We want to add a key. So this is knowledge that we already know how to do. So it's the dictionary name plus the bracket. So we want to add a key that's supporting actress. We want to set that equal to Viola Davis.
Let's see.
Weird.
You might have to, yeah.
I have to, yeah, this is a little hacky, but yeah, cool. It's the our internal view. Sorry about that. And then now instead of changing, I don't know if you all remember this, but there was a whole mix-up at the Oscars a few years ago where they falsely announced La La Land as the winner of Best Picture that year, but it was actually Moonlight.
Yeah, it was a funny example.
Yeah, let's correct that mistake by now updating Best Picture to Moonlight. So I'm just gonna refer to the key here, and it's very simple. Now it's should be Moonlight, and let's print the Oscar winners at the end to see our changes. Cool. So best picture, Moonlight, and everything else is in place as well. Cool.
Nice. Yeah. The thing to note there is that the syntax is almost is identical for creating the key in the first place and then also editing it.
Yeah, exactly. Okay, list comprehensions. Those are some big words. Okay, let's say we have two lists and we want to combine them into a dictionary. Cool. Take some wizardry, but Python actually allows us to kind of like zip these things together pretty seamlessly. So that's exactly what it's called. It's called zip, right? So this syntax, which is, I don't know if you all have covered list comprehension so far, Alex, but list comprehension, there's always kind of like a shortcut somewhere, and that makes the code feel like accomplish a lot in a single line, right?
Yeah, I think that this is a good example of like if you're working with a program that has your data organized in one way that doesn't make a ton of sense, right? You could see this line of code on line 2 is caffeine 64 40 0 120. Like in a vacuum, that makes no sense, right? Like what is 64? What is 40? What is 120? So sometimes your program might be using data structures that aren't the best. And so this is just a good way to show, hey, how do we like combine these in a way that makes slightly more sense or makes it slightly more useful. So we don't have to remember, oh, right, espresso was the first one in that list.
Yeah, exactly. So, I mean, we can take this line and kind of apply it to this like coffee example here. So let's kind of break down that line a little bit. So let's look at the end first where it's like zip names and heights for this example. Zip name heights returns a series of tuples, I believe, right? So tuples are pairs. It's like X, Y, essentially. And it's saying like, let's name each tuple a key and a value, right? Doesn't really matter what those variables are, just as long as like we reuse the same like key value variable names here. So for every key value in the like tuples that's returned by zip, we create a pair that's connected by a colon. And then this whole thing is surrounded by curly braces, right? Okay.
Yeah, it's a little bit of fancy syntax. I can talk a little bit more about it as you're doing the instruction here.
Yeah. Yeah. So let's call this zipped drinks, and I'm gonna copy this line over and just change some of the variables. So instead of names and heights, we have drinks and caffeine.
Zips and caffeine together.
So the drink the drinks contains all the keys that we want. The caffeine contains all the values that we want. So
at the very start, you're setting it equal. Zip drinks equals students equals. Get rid of that students.
Oh, whoops.
There you go.
That is zipped.
Can we try to print out zipped drinks to see what it looks like?
Yeah, I think this is expecting like an intermediary step where we zip the drinks. Although that looks like a dictionary.
Yeah. So we did it all in one step. So first they were expecting us to do zipped drinks is just the zip function, which zips together the two lists into a list. And if we print this out, it's actually going to be an ugly print statement. Do you want to print?
It's going to be a zip object.
Yeah. Can you throw a list around that? Can you cast it as a list?
Like this?
So list and then normal parentheses around it. Yeah.
Got it. Cool. So it's a list of tuples right now once it's zipped. So then that makes sense for this line right here where we're searching for, where we're basically going through each tuple in the list. We know that they're comma separated. We'll name one of these key and one of these value. And we'll now rewrite them in that syntax. Cool. I'm going to complete this exercise by now adding the list comprehension to this zip result. I'm actually gonna just call that drink caffeine so that you all can see that you can use whatever variables.
Yeah, there's nothing magical about that key value variable name.
Mm-hmm. So can print drinks to caffeine. Cool.
Thanks. That's awesome.
Yeah. Definitely like review this part a little bit. We should move on to the next lesson, which will give us a lot more information too about accessing all of the values all at once, or all of the keys all at once. Cool. So this is basically like the review part of our lesson. If you've taken any Codecademy lesson, there's always a little like wrap up at the end. So in this lesson, we've created a dictionary. We've added elements meaning keys and values, updated them, and at the end, we've learned somehow how to do the list comprehension to create a dictionary from existing lists. Cool. And I'll leave you guys to complete this review exercise on your own. So let's move on to the next lesson, which is more applications for dictionaries. Cool. Cool. So I'm just gonna, I think we skipped the intro in here somehow. Okay. So now that we've got kind of the syntax down, we want to start thinking about like how to solve problems, some of the functionalities of dictionaries, right? So we'll be able to use get a value from a key. We'll be able to check if a key exists. We'll be able to see how big the dictionary is, or how long, the length of the dictionary. And we'll be able to go through each pair of keys and the values.
Yeah, I think the first lesson really focused on let's create dictionaries. And now it's like, okay, now that we know how to create dictionaries, what can we actually do with them? So we can start to play around with these.
Yeah, cool. I like the exercise here, the zodiac.
Yeah, these are all fun. I love them too. This is a fun couple lessons.
Yeah. Cool. So in this exercise, we'll be learning how to essentially get like values from a key. So let's just directly go to the instructions here. Let's print out the list of zodiac signs associated with the Earth element. So if we see here, the different elements are the keys, and the signs associated with each element is the value of that key. So we have a key Earth here, and it tells us to print. So I'm going to do a print statement around zodiac elements. And again, just like lists, you can index by the name of the key. So that's really convenient, because then this is all we have to do, right? We can just refer to the key name, and we get Taurus, Virgo, and Capricorn. Cool. And then let's just print out the fire signs too while we're at it.
Yeah, while we're doing fire, how about we try to get exactly Leo? So how would you say, okay, now that I've gotten the key, how do I access the first element from that list?
Yeah, so if we notice, the value is actually a list, right? So that means whatever's, I mean, this is us with the knowledge that Leo is a fire sign. So we know what fire returns, a list, and we know that in this list, Leo is the second one in the list. We're indexing from 0. So that would be index 1.
Nice.
So let's try that. Cool.
Yeah. So obviously that took knowledge of us like seeing the dictionary there, seeing, okay, fire go the key fire goes to the value of this list of 3 items, and then we can see, okay, Leo is the second item in the list, so we can index it from using index 1. So obviously we like kind of have the information here, but I think that that's a good example of like you can start to chain these things together. First you say, okay, I have my dictionary, I want the value associated with fire, and then once I get that value, I want the first element.
Yeah. Yeah. Cool. And you can even loop through this list once you get it too.
Yeah, good call.
Cool. All right. Let's say that we are searching for something that doesn't exist, right? So I'm gonna like skip past the example in the story there, and let's work with the example we have in our code editor. So here, this code that it's already there is trying to print the zodiac elements associated with an energy key. But energy is not a key in the dictionary. I mean, what we can do though is add a key called energy. And the value should be, it's not a zodiac element.
Yeah, this is actually similar to how in lists, you can only ask for elements up to the length of the list, right? If I have a list of 5 things in it, if I ask for the item at index 10, you're going to get an error. It's pretty similar here where we only have available the stuff that the keys that are actually in the dictionary.
Exactly. Cool. So this fixed our key error here because now we've actually created a key for like this line to access. Okay, let's move on. So, I mean, typically you really don't want to be kind of caught with a key error because most of the time you may not know what's exactly in the dictionary, right? So there's a bit of, you want there to be some sort of like backup if you can't get the key. You don't want your code to error out and stop executing completely. So this is where a try except kind of block allows you to attempt to get a key, right? And then if there's a key error there, that's called, and you can make an exception for that error, right? That's what the except is for. So try this line, and then if there's a key error, make an exception with the code not like stopping on you. And when that error is caught, print or execute this line instead. So let's try to create that structure for this caffeine level dictionary. So we can set it up as sort of a backup plan for if somebody tries to access something later on and it's not there. So what somebody's going to try to do is if someone tries to get matcha, I'm going to try to print the caffeine level of matcha. So we'll try to get that. And if it's not there, it's going to cause a key error that we can make an exception on and can print unknown caffeine level. I just know this thing is gonna kill me for the case, capitals.
Yeah.
So I'm trying to type carefully. Cool. So that means that this has successfully caught the key error, right? Because let's say we did this line at the beginning without wrapping it in this try except. There's a key error for match immediately, and that prevents the rest of the code from executing, right? So
yeah, this kind of stuff is just kind of good practice for, you don't really
right.
want your program to ever crash. You want to handle these
Mm-hmm.
errors elegantly, like rather than program crashing it, giving you this ugly error message. Instead, you can anticipate like, okay, if the key matcha doesn't exist, let's print this thing in particular to give people a clue of as to what happened.
Yeah, cool. I wonder if we want to.
Yeah,
Well, we'll
let's
have to
maybe
get through some of these, I think, to do the code challenges later on.
Yeah,
But I think I want to get all the keys and then
yeah,
get
actually
all
get
values.
yeah, we definitely need get all values to do the code challenge. So let's try to get to that.
Okay, cool. So above this block, you can actually add an entry so that it doesn't fail. Let's move on to so essentially there is a better or safer way to get a key that is not just simply indexing, right? So what's really nice is that Python Dictionaries also has another built-in function called get, and what that does is actually handles the key error for you. And you can use get to specify the so what the get will do is it'll default return none if there is no key, but you can also set like a default return value for get if that key is not found, right?
It just makes it so you don't have to write that
try
by
except
except every single time you're trying to like access keys.
So I'm just gonna do like a short one here. So let's just print the result of trying to get this entry, Terracoder. That's so Terracoder is a real one, but let's say that like I made a typo in here, right? So then the get would return a none instead of a key error, right? And then you can follow the rest of this exercise to learn how to practice adding a default value if there's no value associated with the key that you're looking for. Do we want to move on?
Yeah, let's move on.
Okay, cool. You can also delete a key, which comes into handy. And you can delete it using this thing called pop. So just like I want this popped off. So that's a way to remember that pop function. Let's just try it in this example where we have some sort of menu thing again, the items and their prices. So this isn't a game. Okay.
Carolyn, earlier we were called out for not knowing the that language in the other example was Elvish from Tolkien. It was one of Tolkien's languages.
Okay. I don't see why like we were being called out because
no, I'm kidding. They definitely were joking.
Yeah. I had a feeling that was that.
Yeah.
In one line. Okay, this is kind of a long instruction.
Yeah, I think let's just see what happens if we pop pop something specific. This is not super relevant for the code challenge, so I feel like we should move on.
Okay, so let's say we want to get rid of this power stew thing. And to check that, we can print it right after the pop statement. Cool. So we can ignore that error right there because we're kind of going rogue from the lesson. As we can see here, after this pop, that entry is no longer there. We can also get all of the keys all at once. This is going to be really relevant for our code challenge. And what you have to do is simply use this .keys function that's also built into the dictionary. So let's say I want to get all the keys of the user IDs. I'm going to print the keys.
Yeah, so it's kind of in this weird format. It's kind of looks like a list. And I imagine we could access the first one by can we do user IDs dot keys and an index of 0 to see if we get Terracoder?
Yeah.
Yeah. So it's a dict keys object. So we could eventually do some funky stuff like casting it to a list.
Right.
And then
we can actually iterate through it. So this is where we can loop through things. So let's say I want to do, let's say user IDs.keys, and that way I can print.
You need a colon at the end of line 6.
Colon, right. Cool. So now iterating through it, I can isolate out all of the keys and print them out one by one. Cool. So that's relevant knowledge. We'll move on to the next one, which is get all values, which is also very similar, dot values. So let's just do the same thing where we are looping through the values for num in num exercises dot values print num, and that returns us all the values. We can also use a list to cast the values. So let's say we want to do that for this exercises thing. I'm just going to like wrap the print statement around so we can see it directly. Cool. So we can cast the values to a list and just print that list directly as well.
Yeah. One thing to note here is that, again, dictionaries are unordered. So Carolyn, before line 3, could you add a new key? Just like we can just make up what we want it to do.
Add in a new key.
Yeah. So new exercises of Carolyn is, or whatever, is 100. And it's not quite the syntax. It's going to be Carolyn.
I'm sorry.
You're good. You're totally good. It's hard to do this on the fly.
What?
Let's see.
It's a typo.
There you go.
Okay, cool. So now you can see I've been added to the values.
Yeah, it just kind of gets tacked onto the end. One thing to be aware of is that I actually didn't know if that would be tacked onto the end or not, or if it would have been inserted someplace weird.
Right.
You can't really rely on dictionaries in being in this order of like, okay, the thing that I added is always going to be at the end.
Right.
It's definitely more of a list thing. And because we're working with dictionaries, which is unordered, you can't really rely on that.
Right. I
Cool.
think it's for like this like pretty small dictionary.
Yeah.
It's relatively I mean, I think especially if it's hard coded as well. I think it might look different. Well, you guys can play around. But just know that, it could be unordered, and don't be surprised.
Yeah, in fact, you'll see, I think we should jump to one of the code challenges now, and you'll see that the kind of questions that we ask about dictionaries don't rely on an order of anything. We're either like summing up all of the values together, in which case the order obviously doesn't matter. We can just sum them up in whatever order we want.
Right.
Or so just the order typically doesn't matter when you're dealing with dictionaries.
Yeah. And just real quick here, you can also grab the items. It's also going to return it in that like kind of tuple form. So you can use that same thing we're doing, similar to when we're doing list comprehension. We can just create like temporary variables to stand in for those tuples. And you can iterate through all the key value pairs as well that way. Cool. Nice. Let's move on to the code challenge. I'm going to keep this lesson open just in case we need to like flip back. Cool. So now I'm in the code challenges, which is like, if you actually go to up next, that's what it is. I'm just going to go back to the syllabus here since I already have this open. The syllabus will be nice for me to go back to a lesson if I need to. Cool. So there's 3 challenges here. You want to tackle?
Yeah, whichever one you want. I think let's do 1 or 3 because that involves looping through the values. Maybe 1. I think 1 is maybe the best one.
Let's do 1. And it's pretty straightforward. This code challenge wants us to write a function. So that's knowledge from a previous module. And we want to call that function sum values that accepts a dictionary. And the function should return the sum of the values of the dictionary. So thinking through that, let's write like the syntax of the sum values first. So I think it's def. I'm not a Python coder.
Yep, you got it.
Def, call it this function name sum values, and it wants to take a my dictionary as a parameter. Yeah? Okay. And inside of this function, we want to get all the values. So I think if we think back to like just a few minutes ago when we were learning like the dot values function in the dictionary, we know that my dictionary dot values is going to return us that like dict values type of data form, and we know at the very least that we can iterate through it, that we can loop through it. So if we loop through it, that's going to allow us to kind of like take each value as they come and add it to like a sum, like a running total of some kind. So I'm going to start a total of 0 at the very beginning, and I'm going to write a little for loop to go through that values. So for, say, let's call it val. Is this syntax looking right, Alex?
Yep, that looks good to me. So we're gonna my dictionary.values again is taking is that list type object. It's not exactly a list, but it's something that we can loop through. We're gonna loop through that and store every value in this variable called val, and then we're gonna want to do something with a val.
Right. And we're gonna want to add the val to the total. So we want to update that total every time. So we can either do this, which is set total equals to total plus the val, or we can use like a shorthand here, which is the plus equals. Yeah. And that's it for our for loop value or our for loop code, because it just has to add the values, right? And then at the end, we want to return that sum that we've been keeping track of, which is total. So I'm just going to run this just to check the syntax. Okay, so nothing is, it's great that there's no error messages. So this is convenient. We can uncomment the function calls below to test our sum values function. So I'm going to uncomment that first line first. And we know that this should be 5 plus 2 plus 3, which is 10. So awesome. Cool. So that's the output of sum values on this dictionary. And let's print the next line. In this case, the values are 1, 2, and 3. So the sum should be 6. Awesome. Cool. We are at 2 o'clock right now. Should we keep going, Alex, or?
I think we should probably call it here. But before we go, again, a thing that I like to stress as we get to these code challenges is to, don't always immediately go to our like check answer button down in the bottom right corner. Like Carolyn, I think if you scroll down and hit check answer now, you should get your little like you were right.
Right.
I would say one thing that I notice a lot with people using Codecademy is that they are really into like making sure our approved thumbs up or clap emoji or whatever they get that. I think the more valuable thing is to build out the function on your own without really having to rely on us like checking for whether or not you got it right. So so if I were struggling with this, something that I might do is inside that for loop, I might print val. And so
right.
Yeah, exactly.
So
now I can see, okay, when I pass this, when line 10 is getting called.
So
yeah,
I'm gonna uncomment the other prints.
And the function's not even getting called, right?
Whoops.
Yeah, so now I can see, okay, I have 5, I have 2, I have 3, and then at the end of the day, those all sum up to 10. So doing stuff like that, I think is probably the most important thing that you can be doing in these code challenges. Of if you're getting lost and confused and you're not exactly sure what's going on, just and you're gonna have to cast the val to a string if you do str.
Whoops.
Yep. Doing stuff like that really can kind of help you understand where you are in your process. It can help you develop like a plan of action of, okay, I'm not, I have this value, but I haven't added it to total yet. Things like that is really helpful. So doing that rather than just like writing your code and checking the answer and hoping that it was right, I think is really important.
And what I was just doing while Alice was talking was just adding print statements that are a little bit more specific, because you can end up getting like really jumbled if you're printing multiple values in the same code block.
Yeah.
So I've just made it clear whether the number that's being printed is the current value that is being looked at, or it's the running total.
Cool.
Yeah.
I think
definitely recommend. Sorry, what?
Yeah, I was just gonna wrap up, but yeah, go ahead.
Okay, yeah, definitely recommend completing these code challenges, but most importantly, trying to struggle through them on your own. Use these little boxes as your playground. You can also start taking some of these into your own code editor on your computer as well. That's something we encourage. Yeah.
So cool. I think we should probably log off for today, but thank you for watching. Next week is actually going to be our last live stream in this session, and we're going to dive into classes and objects and object-oriented programming. I see Sammy in the chat is asking a little bit about object-oriented programming. So next week will be super relevant for that. And then that's going to be our last session in this little CS101 series. So thanks for doing this with me today, Carolyn.
Yeah, of course. Very, very last thing. I'm sorry. I meant to say this during the whole live stream, but dictionaries are what Python calls these data structures, but other languages like Java calls these, like, you can declare like a hash map. So you'll hear that word a lot. It means the same exact thing as dictionaries. And I'm not sure what they're called in JavaScript. Maybe they're just lists.
Objects
They're just called objects.
Yeah, which is confusing because we're about to get into classes and objects, and that object is different than a JavaScript object, kind of.
Right.
Yeah.
Yeah. But at the end of the day, it's just these key value pairs that exist in all programming languages. Yeah. Cool. All right. Thank you, everybody, for staying on.
Thanks, everyone. We'll see you next week.